discussing some common probability questions that appear on the ACT. Let's start off with question 44. An automobile license plate number issued by a certain state has 6 character positions. Each of the first 3 positions contain a single digit from 0 through 9. Each of the last 3 positions contains one of the 26 letters of the alphabet. Digits and letters of the alphabet can be repeated on a license plate. How many different such license plate numbers can be made? Okay. So I would recommend for these type of questions, we start off by using something called like a slot method. So essentially what we'll do is we'll sketch out the first 3 slots regarding the first 3 positions of the license plate. And we know that these first 3 slots down here are digits. Next, I'd recommend sketching out the next 3 slots representing the alphabets, right? So we can go 1, 2, 3, alphabets. Okay. So now let's take a look. So for this position right here, how many numbers between 0 through 9 are there essentially? Like how many numbers in total are there ranging from 0 through 9? And we can see that that is 10. So we know that there's 10 digits right here. Okay. Now the same thing can be seen for the second slot. Since it says that the digits can repeat, we know that essentially it's the same concept. It's inclusive. It's not there's no restrictions on the amount of digits or anything, since it says that it could be repeated. So essentially, how many digits can fit from 0 through 9? And at the end of the day, we could see 10 digits because there's no restrictions. There's 10 different numbers that can be fit from 0 through 9, from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10. Similarly, we could do the same thing right here. Now moving on to alphabets. So what we see is that there's 26 alphabets and it ranges from 1 through 26 and there's no repeats. Okay, so that's essentially a similar concept with alphabets, except that instead of it being 10, there's going to be 26 because there's 26 letters in the alphabet. And since it says that there can be repeats and there's no restrictions on the what letters or the amount of letters or anything like that, we can write down 26 here and 26 here because there's no restrictions. And finally, all we have to do is simply multiply these out. So it would be 10 times 10 times 10. Okay, now what we can see here is all we have to do is multiply it out, and we end up getting the answer of K after we multiply this out. Okay, let's move on to a similar question. Question 48. 6 plants, each of a different plant type, are to be arranged on display shelf 6 spots. If each spot must have a plant, in how many different arrangements can the plants be placed? Okay, so in order to solve this question, I recommend that we implement the slot method we did earlier. So we know that there's going to be 6 spots. So 1, 2, 3, 4, 5, 6. And we have 6 plants to choose from. Okay, so now for this first plant right here, out of the 6 plants, how many plants are there to choose from, essentially? And that should be pretty obvious. There's 6 plants to choose from out of 6 plants. But now that we've placed down one of those plants, essentially, let's say we placed down a rose. We can't really reuse that rose since we've already placed down that plant, meaning we've already used up one of the plants. So after we've used up one of the plants and placed it in its own spot, how many plants are there to choose from for this slot? 5, right? And it's the same concept here. So now that we've placed down 2 right here, 2 plants already, how many plants are there to choose from now that we've already placed down 2? 4. And we could see the concept continuing. It would be 3, 2, 1. And essentially, for these type of questions, it's important to remember that we can't reuse a plant after it's been placed. It's not like the last question where we were able to reuse some sort of digit or we were able to reuse some letters of the alphabet. No. Once we place down a plant, we're unable to reuse that plant for the next spot and the next spot and the next spot. And so simply to conclude, all we have to do now is just multiply through is just to multiply through. So we could see 6 times 5 times 4, 6 times 5 times 4 times 3 times 2 times 1. And that should leave us with K, 720. All right, so now let's move on to another similar problem type. So we see that a company prints contest codes on its fun-sized bags of candy. Each 6-character code consists of the letter A followed by the letter H, followed by 4 of the digits 0 through 9. The digits may repeat. Which of the following expressions gives the number of different 6-character codes that are possible? Okay, so it's a similar slot method here. We see that there's going to be 6 slots again. So we'll just do 1, 2, 3, 4, 5, 6. And we see that it says that the code must be followed by the letter A followed by the letter H. Okay, so essentially it's saying that these two characters of the code are already locked in. We know that they already have to be an A, and this one has to be an H. So if you think about it, how much of a say did we really have, or how many options did we really have when choosing between this one and this one? Between this one and this one? How many options did we truly have? And essentially, we had no options here, right? Because there was only one option choice for this and one option choice for this, right? So we can get rid of that. So we only had one option choice for this and one option choice for this. Okay, now let's move on to the rest of the 4 digits. We see that again that can be followed up with the 4 digits 0 through 9, and the digits may repeat. Okay, so it's kind of similar to the very first question, where essentially we'll have, for this one, 10 possibilities, right? Because we have 10 options from 0 through 9. And since they can repeat, we have another 10 options right here, another 10 options right here, and another 10 options right here, since all of these digits can repeat. So essentially now, similarly to what we've been doing, all we have to do is just multiply it out. So it'd be 1 times 1, there. You essentially just multiply all of this out, and what you're left with, you should be left with F. Or actually, we didn't even have to multiply it out. We could just look at our answer choices. Okay, 1, 1, 2 1s, 4 10s. That's exactly what we have right here. So F is our best answer choice. Okay, now moving on to the last probability question of the day, question 51. Get a Great Read Books is adding a new phone line. The phone company says that the first three digits of the phone number must be 555. But the remaining 4 digits, where each digit is a digit from 0 through 9, can be chosen by Get a Great Read Books. How many phone numbers are possible? Okay, so we could just go back to the classic slot method. So let's start off with the first 3 digits. It says that the first 3 digits, 1, 2, 3, of the phone number must be 555. Okay, so we can just write that down, 555. Great. Now let's go down to the remaining 4 digits. The remaining 4 digits, where each digit is a digit from 0 through 9, can be chosen by Get a Great Read Books. Okay, so 1, 2, 3, 4. And it says that where each digit is a digit from 0 through 9. Okay, so it's the same concept as earlier. How many numbers can you choose between 0 through 9? You could choose 10 numbers, right? And since it has no restrictions on repeating digits or whether or not the digits can or cannot be repeated, we could simply just assume that it's okay to repeat the digits. So we could say that, okay, 10 numbers can be chosen from 0 through 9, 10 numbers can be chosen from 0 through 9, 10 numbers can be chosen from 0 through 9. Okay, so now let's look at our answer choices and see which the best ones are. Now, a common trap right here would be choosing A, B, or C. A, B, or C. And the reason this would be a common trap right here is because, well, let's look at the first 3 digits, right? Did we have any real say within these first 3 digits? How many, or as we've been doing earlier, like how many digits have we had the option to choose from? For the first one, for example, for this one, we only had the option to choose between one digit, and that digit was the number 5, sorry. And for this one, again, we only had the option to choose between one digit, and the option was only the number 5. And similarly for this one, we only had the option to choose between one digit, and the option was only the number 5. So if we write this down, we only had one option to choose from here. We only had one option to choose from here, and we only had one option to choose from here because it was already locked in for us in the original equation. It said that it must be 5, 5, 5. And so therefore we had no other options to choose from. Whereas, for example, these ones right here, we had options to choose from. We actually had 10 options to choose from, picking from the numbers 0 through 9. Okay, meaning that if we just go back to our, the same process we've been using, we could see that we could just simply, let's see, just get rid of this, get rid of this. Since we had one option times 10 times 10 times 10 times 10, so we could just put the multiplication right here. And what we see is that the best option we have is option E, where we had 10 options, and because the 10 times 10 times 10 10 10 is just equivalent to 10 to the fourth. And 10 to the fourth times 1 times 1 times 1 is just 1. So 1 times 10 to the fourth equals 10 to the fourth, which matches up with option E right here. All right, thank you so much. These are some common probability questions that appear on the ACT. All of these questions were taken from past ACTs, and there's always going to be some sort of variation of these type of probability questions as we've gone through today on your real ACT. So the best advice would be to understand how to use the slot method as we've been using, and simply just practice other probability questions you can find online. Thank you.